Yeah, looking at it, this is more slope. So slope and the rate of change are basically the same thing. And we're going to find that out as we go through and do our next example. All right, so here's our example. And again, when you look at this, you could see it's labeled kind of clearly here that this is your x. D is the same. We're going to say it's basically the same thing as our y in this particular setting. So we're going to go through and we're going to use our slope formula, if you guys remember that from last time. And that formula was pretty simply just how to calculate slope. And your slope is going to be your y2 minus y1 over x2 minus x1. Okay, and if you remember, we talked about this last time, that the numbers that you see here, the y2 and the y1, those numbers are subscripts. And in math, the subscripts don't have a value. It's not telling you to do anything to the number. All it is it's help identifying the number. So like we talked about the last time we talked about slope, it doesn't matter which 2 points we pick. And we're going to do this with a couple of examples. Okay, so let's pick point. We'll make this one 0.1 and this one 0.2. It's kind of simple to do that way, which means that this is going to be, let's just change our color here so we don't confuse people. This is going to be our x1. This will be our x2, right? Because that's a 1, that's a 2. Then this would be your y1, and this would be your y2. So we'll substitute the numbers in. So our y2 that we see here is going to be our 500. So it's going to be 500 minus, and now let's find our y1. Our y1 is going to be this one. So that's going to be 250. And that goes over our x2, which in this case is a 2, and our x1, which in this case is a 1. So we subtract, and we were going to get 250 over 1. So that means basically our rate of change is 250. And using it in the context of this problem, that means for every 1 minute, we're going to be 250 feet further from home. Okay, so again, our slope in this case, which is our rate of change, is going to be equal to 250. Right? So now we're going to use two other numbers, and we'll see how that works. Example, we're going to use two different numbers. And again, it doesn't matter which numbers we pick. So let's pick, this will be our 0.1. Okay, and this will be our 0.2. And again, if these were written as ordered pairs, 0.1 would look like this, 3, 750. And 0.2 would look like this, 5, 1250. Okay, again, you don't have to write it that way for the table, but again, just so you understand how to relate the table to a set of points. Okay, so let's go through, let's calculate our slope. And again, our formula is going to be y2 minus y1 over x2 minus x1. And we've determined which is 0.1, which is 0.2. So our y2 in this case is going to be 1250. Our y1 is going to be 750. And our x2 is going to be 5. And our x1 is going to be 3. So when we subtract this out, we're going to get 500 over 2, which reduces to 250, which is the same thing we got when we used the other 2 points, right? If you remember back, we used this point and this point, and we got a rate of change of 250 feet per minute. And now, again, using 2 different points, we used these points, and we got, again, 250 feet per minute. So as you can see, rate of change and slope are the same thing. They can be calculated the same way. It's just using the context. In this case, our x is minutes and our y, or in this